Hi, hello, welcome back students. Again, we'll solve one more important example on application of integrals. So previously we have solved an example on ellipse. So now we'll solve another important example of one more different kinds of geometry, that is equation of circle. Let us say, using integration method, find the area enclosed by the curve x square plus y square is equals to a square. And you should know what are the equations and associated their geometries. Okay, so x square by a square plus y square by b square is equal to 1 is the geometry of ellipse. So now here x square by a square plus y square by b, x square plus y square is equal to a square is the equation for circle. You should remember the equations and their geometries, then it becomes very easy. Okay, so what we say, this is equation of circle with radius as a. Okay, instead of a, sometimes they mention as r also, small r. This also represents the radius. Okay, they'll mention r square also. So this is equation of circle with radius a. So this is your equation of circle with O as your center, 0, 0, and this is the point A. I have taken it as A, and from center to anywhere on the circle, you know what it is? Yes, we call it as a radius of a circle. सेंटर से जहां पे भी आपको एक लाइन लेंगे इन एनी डायरेक्शन, वो क्या होगा, हमारे को क्या होगा, रेडियस ऑफ ए सर्कल. So 0 to here is r, 0 to here is radius, 0 to here is radius, 0 to here is radius, 0 to here is also radius. From center to anywhere on the circle. Okay, so here say, here what we have, radius. On this axis again y is 0, so we'll take the point as a comma 0. Again here to here, what we have, radius. Yes, radius is what, a. Again on y axis, x is 0, the point will be 0 comma a. Now again there are 4 areas or 4 quadrants, you must say, and here also all are equal. If you find first area and they are equal to other 3, and we multiply it by 4. Simple. Let us find the area of the first part. Okay, let us see. As of the previous problem only, we write it as area is equals to 4 times of area of OAB. OAB. I'll take this as B. Fine. Okay. And this is as of the previous, and again only area is equals to 4 integration from 0 to a y dx. We'll take it as equation number 1. Again, what we need? We need the value of y. Y is obtained by using the given curve. The given curve is x square plus y square is equals to a square, and we'll bring this into the RHS to get the value of y. Let us see. So y square is equals to, it becomes a square minus x square, plus x square becomes minus x square, and I need y, so y becomes square root of a square minus x square. That's it. This is our y. Is it easy now, right? Let us use this y here, then integrate. Equation number 1 becomes, what it becomes, area is equals to 4 times of 0 to a. Again, a remains the limit as it is, because in generally the radius he has given it as only a. If he has given a number, then we would have taken the a value here. Okay, general in kotta nodri, a ne kotta. Okay, a ideye so hai, so we'll take a as its limit only, because radius is not mentioned in the numbers. So y dx, y is this one, root a square minus x square dx. Now all of you know how to integrate this quantity. Those who have seen my previous class, that is first example on application of integral, that is ellipse, same formula is used. There is nothing changed. Almost we have 3 to 4 examples. In every example, the integration part formula remains the same. This is the bonus for you. If you remember only one formula, you can easily solve the others. Just taking out the y from the equation is only the thing different, and it's geometry, isn't it? That is. So what is the formula? 4 as it is, x by 2 root a square minus x square plus a square by 2 into sine inverse of x by a, and its limit 0 to a as it is, because we didn't apply the limit still. Okay, I keep 0 to a as it is it? This is your direct formula of this one. Okay, let us see. Next, what we do? Okay, let us apply the limits. So 4 as it is, let us apply the upper limit first. Okay, so upper limit 11. How to apply the limits? Let us see one more time. So you have integrated with respect to dx, in the sense your variable will be x. How to apply the limits? Upper limit minus lower limit. Upper limit is what we have, a, lower limit as 0. So wherever we have x in this integrated term, integrated part, you use x as a as upper limit. Keep it minus as it is. Then again use x as 0 as its lower limit. Okay, let us see. Wherever you have x, we'll use a. So here it is x. So it will be a by 2. Again root this a square as it is minus as it is. Again we have x. X will be again upper limit a. So we have a square for it. So square as it is. It's simple, right? Plus there is no x, a square by 2 as it is, into sine inverse of x by a. Again we have x. X as a by a. This is our upper limit. Formula says minus lower limit. Lower limit is 0. Wherever you have x, you apply 0. Here you have x. X is 0. The total term becomes 0. Total term in sense 0 into anything is 0. So this term becomes 0. Plus a square by 2 as it is. Into sine inverse of x is 0. Into sine inverse of 0. Because 0 by anything is 0. 0 by dunya is 0. 0 into dunya is 0. You already know this dialogue, right? Okay. Let us use the values. What are the values? A cancels. Okay. What are the important values we need here? Sine inverse of 1 and pi by 2 and sine inverse of 0 is 0. You all know these two values. Okay, let us apply. And what this becomes? Root a square minus a square. A square minus a square is 0. 0 into anything is 0. 4 into, so this first term becomes 0, plus a square by 2 as it is. Sine inverse of a by a cancelled 1. So it will be sine inverse of 1. Sine inverse of 1 is nothing but what? Pi by 2. Remember these formulas. Minus. You just leave the 0. Next what? A square by 2. Okay. If you want, you can write a square by 2 into 0. Because sine inverse of 0 is 0. 0 into anything will be 0 in the next step. Otherwise, you can write here only as 0. What are the remaining terms here? For a square pi by 4 minus 0. This total term is 0. Now you can cancel 4 with 4. What is the remaining term? Therefore, a is equals to only pi a square roots. Is it simple? Isn't it? Just have a glance over this. You can easily solve the problems. I hope you're understanding these. If you understand this, so if you didn't subscribe, if you did not like it, if you did not share it, please share, subscribe and like. We'll see one more important examples on this. Let us look into this. Okay, my dear students, welcome back again. We'll see one more important example on application of integral. That is, find the area bounded by the curve y is equals to sine x between x equals to 0 and x equals to 2 pi. Okay, and the previous two examples what we have seen, ellipse as well as circle. We directly know the geometry and we have drawn it and we have find the area. Now you should know what is the geometry of the sine x. You have seen this geometry in the introduction to trigonometry in class 11, isn't it? So there you have seen the geometries of sin x, cos x and tan x also. Let us see. And we draw the sin x for 0 to 2 pi intervals. Let us see. Okay. This is your x-axis and this is your y-axis. This is 0 and this is pi and this is 2 pi. And this is your sin x function. So this is nothing but the standard angles are in between. You might have this as pi by 2 and this as, I'll write here, this is 3 pi by 2. The standard angles are 0, 90 degree, 180 degree, 270 degree and 360 degree in between. Okay. So you can see we need to find this whole area. This is one, you can call it a sine wave also according to physics, right? So this is to be found, area of this and area of this. So it can be solved in two ways also. We'll see the easiest way to find the area. And you know, as of the previous classes, the area of this is equal to the area of this. This is positive wave, this is negative wave. Because how we are saying positive wave? And this is your x-axis, above x-axis, below x-axis. Above x-axis positive y values, below negative y values. And you know the range of the sine function. The highest value, the highest range of the sine function is +1 and the lowest value is -1. And this will be your +1 and this will be your -1. Yes, very good. That is why one will be negative and one will be positive. Let us see. So y is sin x between the curve x equals to 0 and 2 pi. This is given. Okay. Now area is equals to, so integration of 0 to 2 pi. If you say in general it is 0 to a y dx also, as of the previous classes. Let us see. Okay. So 0 to a is what here it is 2 pi y dx. The total value here to here 0 to 2 pi. But this is divided into two areas, two separate areas with separate integrals. What it is? One here to here one area and here to here another area. Here to here in the sense 0 to pi one area in the positive way, pi to 2 pi another area in the negative way. Let us see. So 0 to pi sin x dx, because y is sin x, plus pi to 2 pi, pi to 2 pi. It is negative value, so I will take it as minus sin x. Simple. Positive value, negative value, plus sin x, minus sin x. Simple. Plus sin x and minus sin x. Now let us integrate them. Integration of sin x is, you should know, integration of sin x dx is what? Minus cos x. Let us see. So it is minus cos x, limit as it is 0 to pi, plus already one minus sign is there. Integration of sin is again minus. It becomes plus. This is pi to 2 pi, isn't it? As of the previous values, upper limit minus lower limit. Okay, let us see. So minus sign as it is, upper limit is cos pi minus lower limit is 0. Where you have x, use upper limit as pi. Where you have x, lower limit as 0. In between this plus as it is, same here. Cos 2 pi as upper limit minus pi as lower limit. Upper limit minus lower limit, plus as it is. Upper limit minus lower limit. Simple. And just use those values here. Minus. Cos pi value is minus 1. Cos pi is minus 1. this minus as it is. Cos 0, already you know this. Cos 0 is 1, isn't it? Plus as it is. Cos 2 pi is, yes, it is not minus 1, it is plus 1. And minus as it is again, cos pi as of here is minus 1. Cos of odd multiples of pi, which means cos 1 pi, 3 pi, 5 pi, 7 pi, always minus 1. And cos of even multiple of pi, for example, cos 0, cos 2 pi, cos 4 pi, cos 6 pi, all these values are plus 1. Okay, odd is minus 1, even is plus 1. Just simplify this minus as it is, minus 1, minus 2, plus 1 minus of minus 1 plus 1 plus 2. So this is 2 plus 2, this is 4. Therefore, area is equals to 4 square units. Very simple. Okay, plus sin x, minus sin x. Two different areas, two different integrals. Why we have used plus sign here in the sense, first area and second area, we need to add them to get the total area. That is why first part plus second part. Simple integration. Using these values, you need to simplify. You get a 4 square units, isn't it? So I hope you understood this, and I'll give you one important examples for you to simplify yourself. It is related to ellipse. Okay, you just take down the screenshot of this. I'll give you one important example. Okay, is it over now? Okay, let us see. The example is, find the area bounded by ellipse x square by 16, y square by 9 is equals to 1. So hints are, so x square by a square plus y square by b square is equals to 1. This is the equation of ellipse. Compare these two. What we get? A is equals to 4, b is equals to 3. Because a square is 16 in the sense, a is 4. Okay. So your area will be, as of the diagram, so this is your 4, 0, and this is your 0, 3. Y-axis, x-axis. This area you need to find out. This is origin 0, 0. This is exactly same like a first example. The general problem points are a, 0 and 0, b. I have used the points here. The area will be what? 4 times of area of OAB. Done? Area of OAB. 4 times of 0 to a, y dx. 4 times of 0 to a is what? Y dx. How to find y? Using this equation, that is x square by 16 plus y square by 9 is equals to 1. Just bring this into RHS. What it becomes? Y square by 16 is equals to 1 minus x square by, y square by 9 it is 16. You bring this 9 into RHS, it becomes 9. I'll take 16 as LCM here. First example, it was exactly like the general form. Here they have given the numbers, that is 16 and 9. What it becomes? So this is y square. Therefore, y will be what? Square root of 9 is 3. Square root of 16 is 4. Use this here and integrate using the same integration formula, that is square root of a square minus x square formula, where a square will be your 4 square, that is 16. Okay, I hope you understood these problems, and this is very important. Practice them you will compulsory find a question in your examination compulsorily. Okay, so if you find anything, and I want you to comment your answer of this fourth example. Okay, so I hope this concept is very much easy and very much clear to all of you, and I wish you all the best, and please share, subscribe and like. Thank you.